So this session is about Continental Drift Theory in the subject Earth Science for STEM students. This is week 16. So today is January 7. Ito din yung topic for tomorrow morning. No. Tapos na pala, no? Ay, 7 and 8. 7 lang pala. Ngayon, umaga lang ito. So just a date. Okay. Okay. So meron tayong objectives. This module aims to achieve the following objectives. Discuss the continental drift theory and the evidences supporting it. And then realize the importance of Alfred Wegener in the understanding of this theory. By the way, pwede niyo itong basahin Wegener, may pronunciation na Wegener, no? So it's up to you kung ano ang mas madali i-pronounce para sa inyo. I am comfortable pag basahin ito no Wegener. Okay, so yan ang dalawang objectives in today's session. Okay, so continental drift theory is a comprehensive, detailed theory proposed by Alfred Wegener. Now, alam natin, we know what is continental. So, drift meaning be carried slowly by a current of air or water. Is defined as continuous slow movement from one place to another. Pag sabihin natin continental drift, this describes one of the earliest ways geologists thought continents move over time. That's why proposed ito ni German meteorologist Alfred Wegener. So according to him, with a gathered large amount of geologic and paleontological data, most of the geologic time, there is only one large mass, supercontinent called Pangaea. Okay, so I believe familiar din itong Pangaea. Okay, so why was the idea of Pangaea? Why was the idea of Pangaea not accepted at first? Hindi ito na-accept agad-agad, no? So the idea was quickly rejected by the scientific community primarily because the actual forces generated by the rotation of the Earth were calculated to be insufficient to move continents. Okay, so again, continental drift is the comprehensive and detailed theory by Wegener. Now, once we have a single large supercontinent, Pangaea. Okay, so late in the Triassic period, which Triassic period was the first period of the Mesozoic era, which occurred 251 million to 199.6 million years ago, this Pangaea fragmented, and the parts began to move away from one another. Okay, westward drift of the Americas opened the Atlantic Ocean, and the Indian bloc drifted across the equator to merge with Asia. Now, in 1937, we have Alexander du Toit, a South African geologist, modified Wegener's hypothesis by suggesting two primordial continents. One is Laurasia in the north and Gondwana in the south. So in our map, northern part, Laurasia, consists of Eurasia, North America, and Gondwana, we have South America, Africa, India, and Antarctica. So yan ang modification ni Alexander sa hypothesis ni Wegener. Okay, so modified yung theory ni Wegener. Now, continental drift is defined as the large-scale movement of the continent. Large-scale movement of the continent horizontally during one or more episodes in geologic time. The development of the idea of plate tectonics relies heavily on the continental drift. I'll repeat. The development of the idea of plate tectonic relies heavily on the continental drift. Okay, so in 1800s, Alexander von Humboldt noted that there is an apparent fit in the borderline of eastern South America and right side of Africa. Again, so eastern South America and right side of Africa. Na-notice na yung fitting of borderlines in that part ng America and Africa. And after about 50 years, Antonio Snyder Pellegrini, a French scientist, found that the identical fossils in European and North American coast. So may identical, kaparehong fossils sa Europe and North American coast. That's after about 50 years. After 50 years, no? Approximately. So in 1908, this Frank Taylor from USA invoked that formation of the mountain ranges around the globe is due to continental collisions. There is formation of mountain ranges around the globe. It is due to continental collisions. Okay. So aside from the similarities of continental shelf margins across the Atlantic, modern proponents of continental drift have accumulated impressive geologic evidence to support their views. You take note that indications of distributed glaciation from 380 to 250 million years ago are evident in Antarctica, southern South America, southern part of South America, southern part of Africa, India, and Australia. So if these continents were once united around the South Polar regions, this glaciation would become explicable as a unified sequence of events in time and space. So another evidence, glaciation from 380 to 250 million years ago. Evident in Antarctica, southern part of South America, southern Africa, India, and Australia. Okay. Also, fitting the Americas with the continents across the Atlantic brings together similar kinds of rocks, fossils, and geologic structures. So a belt of ancient rocks along the Brazilian coast matches one in West Africa. So moreover, the earliest marine deposits along the Atlantic coastline of either South America or Africa are Jurassic in age, which suggests that the ocean did not exist before that time. So again, similar kinds of rocks, fossils, and geologic structures. Okay, so let us review those evidences. Okay, fit of the continents. So complementary shapes of the coastlines of Europe and Africa. Europe. Okay. Ito yung Europe and Africa. Complementary shapes with North and South America. So Europe, Africa, North and South America. So when you look at the map, no? Okay, it is like a puzzle, no? Na pinaghihiwalay, no? Especially this part ng Africa and South America, this part of Africa with the North America, and part of this Africa with Europe. No, that's fit of the continents, fitting of continents. Ito yung first evidence ng continental drift. Another is that we have the paleoclimate indicator. So that Upper Paleozoic, Carboniferous, and Permian, where Carboniferous is the fifth period of the Paleozoic era, or the systems of rocks deposited during it. So the Upper Paleozoic strata in northwestern Europe contain extensive folds that could only have formed in a hot, wet climate, like the present equatorial region. So in rocks of the same age in equatorial Africa, Wegener knew there were glacial tilates. Okay, so here ang another evidence. Next one, we have the flung fossils. So fossils of a shallow water reptile, Mesosaurus, were found in both Africa and South America, even though they could not swim across the Atlantic Ocean. No? So in the figure, saan yan? Nasa bottom part ng picture. Ito yung fossil remains of the freshwater reptile Mesosaurus. So these blue ones, dito nakita yung fossil remains of Mesosaurus. So since Mesosaurus could not swim across Atlantic Ocean, this is clear evidence that the southern part of America was once connected to the southern part of Africa. Na? So dito, nakikita yung remains ng fossil remains ng Mesosaurus. Another, itong fossil of family of seed ferns, Glossopteris, were found in Africa, South America, India, and Antarctica. Glossopteris. Ito, no? A fern. Fossil of the fern, Glossopteris, found in all of the southern continents, show that they were once joined. No? So, itong green one, so dito nakikita itong Glossopteris Australia, Antarctica, part of India, Africa, and South America. Okay, so yan ang other evidences, no? Far-flung fossil. Okay, another we have fossil remains of Cynognathos, a Triassic land reptile, approximately 3 m long, no? Itong orange, brown, no? So, makikita sa part ng South America and Africa. Cynognathos. Okay. Lastly, we have also evidence, fossil evidence of the Triassic land reptile, Lastimosa. No? Saan ito makikita? Yung nakita dito sa Antarctica, India, and Africa. So yan ang another evidence to support continental drift of Wegener. Okay, next is truncated geologic features. Wegener noticed that there were major mountain building events in the northern Appalachians and in northwestern Europe of the same age. The Acadian orogeny in the northern Appalachians and the Caledonide orogeny in the northern Great Britain and Scandinavia occurred during the Devonian period, yielding extensive faulting, igneous intrusion, metamorphism, and the development of major sedimentary features from the erosion of the rising mountains. So when we say truncated, it's like shortened in duration or extent, or it's like cut, pinutol, no? So geologic time definition is the succession of eras, periods, and epoch as considered in historical geology. Okay, truncated geologic features. Okay. We have questions. Okay, why did Wegener's theory take more than 50 years? It took more than 50 years for Wegener's theory to be accepted. One of the reasons was that it was difficult to work out how whole continents could move. Okay, na-mention ito on the earlier slides, no? Why did Wegener's theory take more than 50 years? So it took more than 50 years again for the theory to be accepted because one of the reasons was that it was difficult to work out, or how difficult it was difficult to reason out how whole continents could move. So it was not until 1960s that enough evidence was discovered to support the theory fully. So the main reason that Wegener's hypothesis was not accepted was because he suggested no mechanisms for moving the continents. No mechanisms for moving the continents. No reason nag-move yung continents. So he thought the force of Earth's spin was sufficient to cause continents to move. Okay, so but geologists knew that rocks are too strong for this to be true. Meaning, Earth's spinning was insufficient enough to move rocks. That is why yun ang reason bakit na-delay ang pag-accept ng theory ni Wegener on continental drift. Okay, next, what causes plate tectonics to move? Okay, so the force that causes most of the plate movement is thermal convection, where heat from the Earth's interior causes currents of hot rising magma and cooler sinking magma to flow, moving the plates of the crust along with them. So ito yung kulang sa theory ni Wegener. Ano yung pinaka-reason bakit merong movement sa continent, no? Okay. So, again, the force that causes most of the plate movement is thermal convection. Thermal convection. So, in physics, there are three mechanisms, or in science, there are three mechanisms of heat transfer. There are three ways that heat could be transferred. Number one is by conduction, second is by convection, and third, radiation. So, nakafocus tayo sa convection to understand why this happened, no? So, when we say thermal convection, we have heat from the Earth's interior causes currents of hot rising magma and cooler sinking magma to flow, moving the plates of the crust along with them. So uh, in this point, since my heat from the Earth's interior, at this point, pag-absorb ng heat ang region dito, this part. And then, once na maka-absorb, magiging less dense, akyat yan sa taas, tulak niya yung cooler region down to absorb heat from the inner core, this part, no? Sa core ng Earth. And then, balik yan sa taas, pabalik-balik. Same with the other convection cell, no? So, what will happen? It is possible na merong movement. Okay, to understand this convection, in simple laboratory setup, you imagine na meron kayong tripod, merong flame, may burner, may flame, tripod. On that tripod, meron kayong beaker, yung beaker containing water. Okay. Now, sa laboratory setup, yung water at the lower part ng beaker would absorb heat from the flame. And once ma-absorb na ng water ang heat from the flame, magiging less dense yan at aakyat sa upper part. So those region na naka-absorb na ng heat, magiging less dense and it would move up at the upper region. Then yung upper region na medyo lower in temperature, no? Di pa gaano naka-absorb ng heat, you move yan doon sa baba. Yun naman yung maka-absorb. Paulit-ulit, akyat doon sa taas, baba na naman, absorb, akyat sa taas, baba. Hanggang ma-attain ang boiling point ng water. So, kung ma-imagine niyo yan, and kung merong object na nakalitaw doon sa water, so makita nyo na there is, due to motion of the region, no? Hot region and cooler regions, merong movement din yung kung meron kayong object na ilagay doon sa surface ng water. So, yan ang hindi nalagay na reason, na klaro na reason doon sa Panchaya. No? Okay. So, convection current in the mantle are much slower than those in boiling water. So, klaro-klaro natin makita yung results sa boiling water. But sa Earth, the rock creeps only a few cm a year. What is cm? 1 cm a year? No? So the rock, the tectonic plates in the lithosphere are carried on the asthenosphere like long, heavy boxes move in huge ruler. So, hindi natin ito by ordinary measurement, hindi natin ito ma-observe, no? So, merong mga geologists na nag-study nito on how the distances, length, no? Nag-increase ba yung separation between land masses? And na-observe nila ito over million of years. Convection currents carry the plates thousands of kilometers. Million of years, thousands of kilometers din. Kasi in a cm in the average, yung 1 cm on the average, no? 1 year yan. So how many years na mag-separate yung isang landmass to other landmass? So, yan ang causes ng plate tectonics to move in relation to drift. Continental drift theory. Okay. Who is Alfred Dreyer? So, He was born in November 1, 1880 in Berlin, Germany. He is a son of an orphanage director. He earned his PhD degree in astronomy in University of Berlin in 1905. He then became interested in paleoclimatology and around 1906 and 08, about 2 years, no, he joined an expedition in Greenland to study polar air circulation. It was followed by the three more expeditions in the same country. He taught meteorology at Hamburg and Marburg. He is also a professor at the University of Graz teaching geophysics and meteorology. In 1912, he presented his theory in lectures and published his most important work, entitled The Origin of Continents and Oceans. That was in 1915. He died on November 1930 during his last expedition in Greenland. So, Wegener's theory is very important in understanding movement of the land masses. Okay, so yan ang second objective in our session today. Okay, for our summary, continental drift theory is comprehensive and detailed theory proposed by German meteorologist Alfred Wegener. So according to him, with a gathered large amount of geologic and paleontological data, most of geologic time there is only one large mass supercontinent called Pangaea. And we have an evidences, fitting of the continents, paleoclimate indicators, far-flung fossils, truncated geologic features. Who is Alfred Wegener? He was a German meteorologist, geophysicist, and polar researcher. In 1915, he published his very important work, The Origin of the Continents and Oceans, which outlined his theory of continental drift. Wegener was a member of 4 expeditions to Greenland. So yan yung topic today about continental drift.